Hello and happy Thursday. Welcome to just a small amount of notes on the product rule. All right, but before we do that, I'm just going to revisit one last time the formal definition of the derivative as a function. The limit as h approaches 0 of, and I said you'll never have to do it again, but you need to be able to recognize it. And if this is confusing to you, it's probably because you never thoroughly and or authentically did section 2.1, because that's a hard one to get your brain around without watching the notes and practicing. Remember, this gives us a function for the derivative of any function at x. So when you plug an x into it, you get the slope of the tangent line specifically there. That would be like this letter A right here. Again, we reviewed these yesterday, but this is something that still sometimes when I give them to BC, they struggle with this. So for this one, it's that h approaches 0 stuff. So what I need to do is figure out, well, I always like to hone in on this x plus h because the function's directly in front of it. This is the sine function. So my f of x in this scenario is the sine of x. Okay? And this gives me the derivative, right? So this gives me the derivative of sine. And had this been an x, and this right here a sine x, I'd be done. But on this one, we're doing it at a specific place when x equals, just a second, I can go grab it. I'm trying to color code things here for you. So this is when x equals specifically pi over 3. And remember, this is f of x plus h minus f of x. And sine of pi thirds is root 3 over 2. So this is the derivative of the sine function specifically when x is pi over 3. Now you don't really need to write it like that, but that's the formal way of writing it. The derivative of sine is cosine. And we're doing it at pi thirds. So you just need to know the cosine of pi over 3, pass the buck back to the unit circle. And the cosine here, you need to have this first quadrant memorized or be able to create it, is a half. So the answer to this first one is a half. Now for this next one, I'm doing the limit as x approaches e. All right? And that's this guy. When we're doing it at a specific spot, not actually even just getting a function, we're saying, well, this is the limit as x approaches, in our notes we said c, of f of x minus f of c over x minus c. Again, I like to hone in on finding that f of x first. My f of x in this scenario is the natural log, but this is the notation for the derivative at that c value. So this is the derivative of the natural log of x at, and my c value here is ln e, which is 1. So this is at e. The derivative of ln x is 1 over x, so will be 1 over e. All right, that sometimes takes a while to settle. That's why I keep going over it. So here's some little notes for 10:08 Thursday. Just the first 3 examples of using what we call the product rule. If you would like to see a proof of the product rule, I have the QR code right there. So when we're taking the product of 2 functions, I'm going to call them f and g again. And we're taking the derivative of 2 products, of a product of 2 functions that are differentiable, which means you can find their derivative. Okay? Then we say that we do the first function, write it down. It's x squared, you write down x squared, times the derivative of the second function, plus the second function times the derivative of the first. And what I'll find myself saying a lot is this, because it rolls off the tongue nicely. First d second plus second d first. So you'll have two functions, a first function and a second function, just so you can, here, I'll write it down. Suppose your y equal x squared sine x, and so that's times. So this would be the f of x in this scenario, and this would be the g of x. My y prime, or my dy dx, is simply first d second plus second d first. And oftentimes we factor these. Not oftentimes, you actually should always factor these. So x cosine x plus 2 sine x. So it's really the product rule. Usually isn't something that causes many issues. Sorry, that's yesterday's stuff. So here we go, example 1. We'll do the first 3 examples. Find the derivative of h, where h, now, okay, that's coming up right here, sorry. So first of all, we call it h prime. And we would do first function, derivative of the second, and the derivative of 5 is 0, the derivative of 4x is 4, so d second is 4, there's first d second plus second, d first, the derivative of 3x minus 2x squared is 3 minus 4x, using our power rule from a couple days ago. We'll clean it up, distribute, lots of like pre-algebra stuff in here as well. So distribute, FOIL, this isn't very fun right now. And then you would combine like terms. And I know you know how to do that, so I'm not going to waste your time combining like terms. But it said, actually, I am going to waste your time because of the next question. So let's go take and do our negative 24 x squared. Looks like we have a 12x, and 24, down 20. I'm at 4 x's, it looks like, and a plus 15. Hopefully I didn't make any mistakes. If I do, they're going to fall out in my next demonstration here. So it said, do we have to use the product rule? Sometimes we do. Like on that one I just showed you on the previous page with the sine x, we had to use the product rule. But because these are two polynomials that I could write as a single polynomial, I can rewrite h. When I FOIL h, I can write it as 15x plus 12x squared minus 10x squared, and then minus 8x cubed. That's it as a single polynomial. And when I have that scenario, I could use the power rule. The derivative of 15x is 15. The derivative of 12x is 24x. Oh, sorry. Let's combine those. Let's make this a 2x squared. Combine like, I guess I could have done them separately, but we should always combine, I suppose. So that's actually with these two combined, that would be a plus, and you bring the power out front, 4x, so it's jiving, and then a minus 24x squared. So sometimes we can do things two ways. Which way is better? I don't know. They're kind of equal, but we have to use the product rule on example 2 for all of these because they're not polynomial functions. I can't write them as a single polynomial. So my derivative, which in this case I call f prime, is first d second plus second d first. The derivative of x with respect to x is 1, or it's the coefficient of the linear term. That's the derivative. So it'd be x cosine x plus sine x. First d second plus second d first. It rolls off the tongue. First d second plus second d first. So my derivative of g, also known as g prime, is first d second. The derivative of x is 1. First d second plus second. The derivative of e to the x is e to the x. So again, first d second plus second d first. And then I factor out the e to the x and make it a 1 plus x, and I'd be done. Now again, there's other questions that you might be asked. It might say, Where on the graph of this function is there a horizontal tangent line? Well, for there to be a horizontal tangent line, the slope has to be 0, which means the derivative has to be 0. So you would replace g prime with a 0 and say, oh, at x equals -1. If it asked for the points, you would have to go plug it in, and you would have e to the negative first times -1, or equivalently -1 over e. So the point at which there would be a horizontal tangent would be -1, comma, -1 over e. Depends on the question. This just said to find the derivative, but just so you know, you might be asked to find slopes of tangent lines, where there's horizontal tangent lines, that type of thing. So let's go to our next one. We're going to be finding h prime using the product rule. First, 2x. D second, the derivative of cosine is negative sine. Remember our good old Saint Cloud, negative Saint, negative Cloud, and it ends the exact same way it began. So that's first d second plus second d first. The derivative of 2x is just 2. I like to put that in front, not in the back. And then the derivative of a difference is the difference of the derivative. So I just need to, I took care of that one. Now I need to take the derivative of -2 sine x. Constant stays in front. The derivative of sine is cosine. So I had a product rule and then one from yesterday. First d second plus second d first. Nothing factors. So I'm going to go, I've got a 2 cosine x though minus 2 cosine x. So I do have some canceling. Now again, I'm going to expand on this question. What if it asked me to find the equation of the tangent line to this curve when x is equal to pi over 2? Equation of the tangent line when x is equal to pi over 2. Well, remember, we need two things. We need a point, and they're telling me pi halves is the x. We need the y value there. Y values are the original function. So I'd have 2 times pi halves cosine pi over 2, and cosine pi over 2 is 0. Minus 2 times sine of pi over 2, sine of pi over 2 is 1. So that's going to be a -2 for the y value. So to get those y values, you plug the x values in to the original function. Okay, so again, this was the question. We're done with that specific question, but I'm adding to it. Okay, you have to add some depth if you want to actually get good at it. Write an equation for the tangent line at the point where x equals pi over 2. So I have the x. I just plugged it in to find the y, and you explain this in your flip grid. Now I need the slope there. The slope is the derivative. Okay, so I need my h prime at specifically what's the slope when x is pi over 2. Well, I plug it in. It's a -2 times pi over 2 sine pi over 2. So it looks like it's a -pi times, and sine of pi over 2 is 1. So it looks like it's -pi. So my equation for the tangent line would be y minus the y I know right here. So y minus the y I know, which would be y plus 2, is equal to the slope times x minus the x I know, pi halves. That's the equation for the tangent line. In order to write it, I needed the slopes of the tangent lines, or the derivatives, and this one required the product rule. Do you see how we just keep digging a little deeper into it? Last up, part D, I challenge you to do it on your own, and we'll just strictly do the product rule on these. I won't add depth to it. So my k prime of x would be first, d second. The derivative of the natural log function is 1 over x. So first d second plus second, which is now the ln x. D first, the derivative of x squared is 2x. When I clean this up, x squared over x is just x. And it looks like I'll get plus 2x ln x. So first d second plus second d first. First d second plus second d first. This is your first exposure in example 3 to just a second. Oh, I thought I forgot to hit record. I was going to try and keep it at 15 minutes. I just hit 15, so I'm close, guys. I'm doing my best. It says the differential functions f and g are defined for various values in the table given below. And where's the question? It must be on the next page. Oh, it is. Okay. So h of x is the product of two functions. We need its derivative. Hello, product rule. So one thing kids do sometimes make the mistake of is thinking that the derivative of a product is the product of the derivatives. Like they'll say, oh, it's x 2x cosine x because it looks good. That's not what it is, okay? It's the product rule. You have to do first, d second, plus second, d first. Specifically for this one, I need to replace x with a 3. So on my table, I'm going to be looking at where x is equal to 3. So my h prime of 3 will equal f of 3, g prime of 3, plus g of 3 times f prime of 3. Once you get it here, you're going to go find all of these off your table. So they had a huge tabular component last year because with the distance learning, the test was, they had a whole problem that was based off a table because it couldn't be Googled or done with photomath or anything like that. So we're working when x is 3 right here. Remember we did first d second, so we did f of 3, g prime of 3, plus second, which was g of 3, d first. So you just read them off the table. So my first was f of 3, my d second was g prime, plus second, which was g of 3, d first is 8. And so you would just clean that up, like negative 36, I believe. I wish these were on the same page, but the next one is also a product of two functions. One of them I don't know, so this is why you couldn't Google it or use any Wolfram or any sort of software. Nothing would be helpful for this because nobody knows what f is. So to take the derivative, that's what this means, of a product of two functions, I use the product rule. First function, square root of x, that I know. The second function I don't know, so I will call it f prime. That's first d second. Plus second is f of x. D first I do know. The derivative of x to the 1/2 is power out front, 1/2. Drop it 1. Disguised as denominator over denominator, so x to the negative 1/2. Or equivalently, root x, f prime of x, plus f of x, and then this is 1 over 2 root x. Okay? Now, we're doing this at 4. Now, the non-tabular parts at 4, which is this and this, are just arithmetic. The square root of 4 is 2 times. Now, I go to my table to find f prime of 4. So back to my table. Back to where x is equal to 4 this time. And I wanted f prime of 4, which is negative 1. So, negative 1 plus f of 4. So back to the table and scroll down again. I'm getting good exercise here. I need f of 4, right? Which was 10. So f of 4 is 10. And then 1 over 2 root 4 is 1 over 4. So 10 fourths. So I have negative 2 plus 5 halves, right? Or equivalently, I don't know if you want to crisscross applesauce it, or if you just want to go common denominator, make it negative 4 over 2 plus 5 over 2, which is 1 over 2. That's fine. Or if you're a fan of negative 4 plus 5 is 1, all over applesauce 2, we're good, but it's a half. So that's it for the product rule of part 1. First d second plus second d first. I think someone's... Hello. Just 1 second.
Yeah, sorry.
Just finished. Are you Sam?
No, I'm Cody. It's been a while.